Hello everyone, welcome to another data analytica video. In today's session we will continue with part 2 of our polars analytics series. And in today's part we'll be seeing window functions, joins, pivot, list and explode, conditional logic when or otherwise, and lazy data frame best practices. Before we dive in, let's quickly review the type of data frame that we worked with in part 1. Okay, so here is actually the data frame that we work with in part 1 with ID, category, and its value, and there is a column with timestamp when this value was recorded, and then we have another small list. Okay, so let's start. Okay, so this will be 5. Window functions and also rolling aggregations, which is very important when it comes to the data analytics part for the real use cases. Okay, so we know that for window functions, use dot over to apply an expression as a window function. Whereas when it comes to time-based rolling, we usually use group by rolling or group by dynamic for time-based rolling in polars. Okay, so let's see how we can do it. Let's create a simple window. What we are going to do is we'll actually do the partition by category, and we will compute running mean of column value. So df with rank equal to, let's say, df dot with columns and pl dot call of value So the first thing that we are going to do is to rank, let's use the dense, and we will do it over category. And we will call it as rank within cat, and the next thing that we're going to do is pl.call value, and we're going to calculate running mean, and that to over category, and we will call it as mean within category. Okay, so let's print this df with rank. Okay, so here we are, and if you look at this, you can see that we have So here it computes rank within each category, and you can see that fourth row has the first rank with having the lowest value of lowest value for the value column, and then you can see that fifth row having the first rank within a category. So this is actually in each category the rows have been ranked according to their value, and also the mean within category is showing value 40.578889 for the C category, and then 42.276 for A category, and then 45.255 for B category. So that's what it does. It actually checks and it does the partition over each category, and then it also calculates mean within category. So this is a very simple example of the window function that we have seen using rank and mean and then over column category. So the next thing that we're going to see is rolling or time-based aggregations. So I'll show you. For this, we will be using lazy data frame, and if you have already watched my eager versus lazy data frame video, you know that Polars has this feature to have the data frame converted to a lazy data frame, which actually checks for all the things that needs to be done before starting the execution. So let's see how it's being done. Rolling or time based, and we will convert to a lazy data frame, and then use group by dynamic for time windows. Okay, so let's have the lazy frame is equal to df.lazy with columns. So we are first converting, not case cast. We are actually casting the timestamp column to a date time, and then we are going to sort it according to the chronological order, and for that we are going to use timestamp. And the next thing that we need to do is use this lazy frame, and then also use group by dynamic where the index column is going to be timestamp. Okay, so first let me write what we are going to do is we are actually going to create a 7 days window based on timestamp, and then calculate number of rows in each window plus average value of each window. Okay, so let's see how it's being done. We have actually taken the index column is timestamp, and then we have this every, which gets the value of 70 or the 7 days, and then the period is going to be again 7 days. calculates for all the 7 days in that window, and then we will have an offset 0. Okay, and then the next thing, like I mentioned, we're going to do is we'll calculate using the aggregate. We're going to calculate length, or we'll call it as n, number of rows or the number of records, and then pl.call value, and then we will calculate mean value, and then we will call average value. Okay, because this is a lazy frame, like I mentioned, unless we call this collect, execution doesn't start. So we need to actually trigger that by using the collect, and then we will actually print this result. So let's run this. Okay, so what we did, we converted that to a lazy data frame, and then we also casted, we did the timestamp to a date time field, and then we sorted it by timestamp. And then the next thing, using the group by dynamic, we actually created this time window where we have selected the index column timestamp, and it creates window every 7 days with a period of 7 days and offset is equal to 0 day. And then we, using the aggregate function, we have using the length and then mean, we have calculated the number of records and also the average value. So let's see, like it actually is in chronological order. If you see, like it starts with 2/1/2025, then after 7 days the next windows, 9/1/2025, then 16, 23, 30, and then we have actually the number of records in each window and then average value under each of it. So this is what we have, and here this is an example of how the rolling based aggregation or the rolling calculate sum can be done using Polar's windows. Using Polar, sorry, not windows, group by dynamic function. Okay, so that's it for the window function and the rolling aggregations. So the next thing that we're going to see is joins and concatenations, which is also very important part when it comes to analyzing different sets of data frames. Okay, so joins in Polars behave as SQL-like. So we need to specify how and also on, whether it's a left on or right on. And then we have two functions which are actually edge-stack for the horizontal concatenation or v-stack for the vertical concatenation. Okay, so let's try to have a join. Let's try to see like the join using, let's first create a new data frame for joining. So what we need to do is create a lookup table. Let's create a lookup table for category details. So category metadata. So cat meta is going to be, we know that we have three different categories in our data frame. So here we are going to create first the category column with values A, B, C, and then description, group A, group B. So A is for group A, B is for group B, and then C is for group C. And then let's give a weight, some more metadata. One, 1.2, and then 0.9. Okay, so we'll do a join, and how we are going to do is df.join and we'll join df or the data frame that we have on category metadata, which is actually cat meta, and then we will do the joining on category because that is actually the key, and then key between these two tables. And then how we're going to do it, we'll use left because we need to get the data to the df from cat meta. Okay, and after that we will be selecting columns ID, category, and then a description, and then value. Okay, great. So here you can see that we have actually 20 rows from df, and everything gets left joined with the description from a cat meta. So here C will be having group C, A will be having group A, and then value being taken from df. So here df.join, and we specify with which data frame and specify with on which column, and then how we are going to proceed, how we are going to join, whether it's a left, right, etc. So this is it, and it's very similar to how we do it in SQL or Panta or PySpark, so I don't think we need further explanation. So the next thing that we're going to see is about hstack and vstack, which I mentioned. We actually use it for concatenation. First hstack, sorry. Okay, so let me create so what hstack does is actually, like, regardless of the keys, it actually concatenates two data frames horizontally. So I can show you how it's done. pl.dataframe, so I'm creating two sample data sets. ID we have, and let's say 1, 2, 3, and then we have category, A, B, C, and then we have another data frame, which is actually pl.dataframe, and it has, let's say, value, okay, and 10, 20, and 30. So the next thing that we're going to do is we're actually horizontally concatenating these two data frames, and how we're going to do it, df h stack is going to be df dot h stack of df1 dot h stack df2. Okay, and print df h stack. Yeah, so here you can see that with no reference to keys involved, here it gets actually just horizontally concatenated. So ID, category, and then a new column gets added value from the next data frame. So it's here, it's horizontally concatenated. And another thing that we need to take into account is actually the number of rows needs to be equal. So let's say I gave another row, but it will create an error that height doesn't match. Okay, so that's it. So here if you have 3 rows, and then the next data frame needs to have the same height or the values. Okay, so this was an example of horizontally concatenating, and let's see how we can do the same for the vertical concatenation, or let's say like how it's actually quite similar to the union in SQL. So we stack for vertical concatenation. So here let's use the df2 is equal to pl dot data frame, and then we can actually use the same column as this one, df1, but we will change, let's say 4 and 5. I think that's it, A and B. Okay, so df v stack is going to be df1 dot v stack df2, and let's print df v stack. Okay, so that's it. Actually it gets concatenated vertically, or it, like in a union in SQL, here you will be able to see that it's actually like, because the rows in each of this data frame needs to be equal, an ID, category, and then you can add as many as rows you need to add. So that's it about join and concatenation. So let's go next to pivot and unpivot. Unpivot, or here in this case it's called melt. Okay, so pivot, we know that it's useful for group by turning, let's say group by aggregations to wide form, whereas let's say melt is actually to, it's a unpivot, so it's like from wide to long. Okay, so let's see how that can be done in polars. And here what we are going to do is we'll actually do the pivot, and we will calculate average value per category for each weekday. df dot with columns and pl dot call, let's say timestamp, and we'll change that to weekday. Okay, and the next thing that we're going to do is pivot, use pivot, and in this pivot values is going to be column value, index, because it needs to, let's say like order it from, or it on weekday, it will show for each category. And the aggregate function is going to be mean. So it can be sum, count, etc. Okay. Okay, dt.weekday. Yeah. So here you'll be able to see that we have each weekday 1, 2, 3, 4, 5, 6, 7. Okay, not exactly in the correct sorting order, but we have all 7 weekdays here, and then you will be able to see that we have columns with each category A, C, B, A, B, C, and then we have its mean value. So after the using the aggregate function mean, we have the value displayed under each category and each weekday. So this is how we can actually do the pivoting to see the average value per category for each weekday. And here we are just converting that timestamp to weekday, because we are calculating by weekday, and then using pivot function. In this, we hear the values which we will see in this table is going to use the value column, and then index is weekday, and we are going to do it on category. The columns are going to be category, and aggregate function is mean. So that's it about pivot. And the next thing that we're going to see is how to do the melt or unpivot. Okay, so let's say we have one table, data frame, and pl dot data frame, and we have id 1, 2, 3, and then we have A having values 10, 20, 30, and then we have B with values let's say 5, 6, 7. Okay, and the next thing that we're going to use is, because we know that this actually comes under category and these are values, so we would like to see it after unpivoting this, because this is actually how after pivoting. And next thing that we're going to do is we'll actually need to see this wide form into long form using unpivot. So wide dot unpivot, and the index is going to be id on columns A and B, and the variable name is going to be category, and then value name is going to be value. Okay, so this is it. And we're actually, like, instead of showing A and B and then values here, or the pivot form or the wide form, we are actually changed it to the long form using unpivot option. So here you can see that we have the category A, and then category B with its values. So yeah, so that's it about pivot and unpivot in polars. So using unpivot, you need to specify the index on, and then variable name, and then value name. So the next thing that we're going to see is working with list and explode. So we have already seen that in the data frame that we use, we have a column called small list with list having list as values, and polars actually has quite native list columns and many list functions. So this is how so when we have a list as column values, then how to list that into a separate row? For this, actually we use explode, and I can show you how it's done. So we are going to explode the list that we have, list column values into separate rows. So for that, exploded is equal to df.explode, and small list is actually the column that we have in our data frame, and let's print exploded. Okay, so here if you look at this, we actually had, maybe I can show it here. Yeah, here this is actually the data set we had, and then we had like one, and then the second row we had two values in that list, 1 and 2, and then for 3 we had 3 values, 1, 2 and 3. So now after exploding, let's see how it has changed. Okay, so for the second row, when we had 2 values, 1, 2, and then for third row we had like 3 values, they all have been actually changed, or they are actually now shown in separate rows, as you can see here. So that is actually the difference after exploding, and we get like in each row that list value. So the expression that we use is very simple, that is actually just df.explode and then specify the name of that column, name of list column. Okay, so the next thing that we're going to see is conditional logic. When or otherwise. So it's a very similar approach, so it's like similar to case when logic in SQL, and let's see how it's done. So it's like this: pl.when, and then specify a condition, and if that condition is met, then we will use this expression, then expression, otherwise we will use another one. Okay, so how we are going to see is df dot with columns, and pl dot when. Let's say what I'm trying to achieve here is, yes, so the cases, so cases like when value greater than 60, then it calls as high. When it's otherwise, when it's between 40 and 60, then it's medium. Greater than 40, medium, otherwise low. Okay, so when it is pl.call value greater than 60, then we will call it using the expression, the literal value high, And then next, when pl.call value greater than 40, then it's medium. Otherwise, pl.let of low, and then let's call this column as value bucket. Okay, so here we have an error. Okay, here. Yes, so here you can see that we have actually now the value bucket column added with let's say like when the value is greater than 40 and less than 60, then it's actually medium, and when it's actually lesser than 40, so it's actually low. And you can see that this all of falls in the right buckets. So this is an example when we have to use the case when logic in polars, and we use like when and then and otherwise. So yeah, that's it for this case conditional logic. And the next part that we're going to see is actually kind of an advanced example. Let's say, okay, convert it to markdown. Advanced example. And here what we're going to do is we're actually, the question is to, let's say, list top 2 values per category. Only top 2. So there are like let's say there are 6 rows, because we have 3 categories A, B and C, and then for each of the category we will list top 2 using dense ranking. Okay, so for this question the approach that we need to take is actually we will be using, of course, rank, and then we have already seen window function using over, and the partition is going to be category because we are going to find out the top 2 values by category. And the next part, or actually like after once we finish with this ranking, the next part will be to filter only top 2 in each category. Okay, so let's see how we are going to do it. So let's create first the ranking data frame. So here df dot with columns, and the value we are actually going to rank pl dot call value dot rank and then dense. And like I mentioned, we'll be doing the partition over category, and then we will call it as rank within category. And the next thing, like I mentioned, we need to, so now when we have the ranking The next thing that we need to do is filtering. Filter when the rank within category is less than or equal to 2, and we can also sort it. Category and then rank within cat, and how for each of them will actually categorize by ascending, so false and then false, and we can print ranked. So here we are, like I mentioned, we have now 6 by 6. It's in the result 6 rows, 2 for each category. First two top 2 rank items are shown, and then we have B with the top 2 again, and then with C's top 2 again. So that's what actually like we have seen the ID number of each of these entries here under the ID column, and then we have timestamp and small list. So this is an example of like how, let's say, top n calculation, how to use or how to actually approach this type of question. And then we have another example, which is actually to compute percentiles per group. So let's say we need to calculate the 75th percentile. And for this we will use quantile, another expression called quantile. So how we can use it, we'll actually df dot group by, because we're gonna calculate on category level, and then aggregate pl dot call value, and then quantile is going to be 0.75, and then alias it will be called p75, and then pl dot call value dot quantile 0.5 dot alias median. Okay, so let's run this, and here you have for 75 percentile under the P75, and then median using this 50th percentile. Okay, so that's it about, like, let's say like we have seen some advanced expressions, some advanced example, and another thing that we can actually do is I'm going to show you how to write SQL-like expressions in Polar. So like I mentioned in the beginning, Polars is very similar to SQL, and SQL is widely used, and many users still prefer to think in SQL. So Polar expressions actually lets you write the same ideas but in Python. And let me get an example. So what we're going to do is, for example, is actually that in SQL, okay, maybe it's better that I keep it. So in SQL, the expression is select category, then average value as average value. Okay, from df, okay, where value greater than 20, and then group by category having average of value greater than 45, and then we will order by average value and descending, and then we will limit to show only 10 rows. So this is an example where we are actually calculating average value by category, where we will calculate when the value is only greater than 20. And once we have this calculation, or the average value will be only taking when the average value is greater than 45, and then we will order it by average value descending, and then we will limit it to show only the top 10 rows. Okay, so this is, okay, maybe I can write. So what we are trying to achieve, when value is greater than 20, calculate average value per category, then show only those entries where average value greater than 45 in order of average value descending, and limit to 10 entries. So how to achieve this in polars? Let's see. Let's start by using a lazy approach, because we hear more when the pipeline involves more operations, lazy is more optimized. So let's say df.lazy. So first we will actually filter when value is greater than 20, and then we will group by category, and we need to calculate the aggregate value using pl.call_value.mean, and we will call it as average value, and then we will have this column filtered, when it's greater than 45, and also after that we will sort it by average value, and descending is equal to true because we need it in descending, and then we have this option to limit entries by 10, and because we use lazy approach here, we need to use the collect. Okay, so great. So here we can see that we have actually, like, it works very similar to how you think in SQL. So we are actually filtering it by first column values, and then we will group it, and then we will calculate the aggregate, and then we will filter on that aggregated column, and then we will sort it and then limit. So only the B category entry having average value for those entries with value greater than 20, more than 45. So only the B category value is being shown here. So this is how the polars actually like calculates, or polars writes expressions similar to SQL. So the next or the last segment of this is to see how best practices usually done in in polars. And we know that when it comes to lazy frame, so always prefer lazy frame for large pipeline because they're more optimized, like I mentioned. And so how it's done, we usually start with df.lazy and then write all the expressions that you would like to calculate, and after that collect to actually say that now the execution can begin. And next thing is, because we have with column and with columns, usually with columns is preferred instead of repeated dot with column, so fewer passes. And the next thing that we have is to avoid dot apply or Python level user defined functions. So polars actually prefers, or polars suggests to use vectorized text expressions more. And another thing is use select to avoid or to prune unwanted columns, because we don't need to have all the columns. If we don't need to have all columns in the results, then we can avoid by using the select function. And yeah, I think that's it for as best practice suggestions. So I hope this session was useful, and because we already covered part 1 and part 2, I'm renaming this notebook as Polars Analytics. And this is like as cheat sheet, like I mentioned, for polars when you want to see how its expressions are often used, how to write, and what are actually like the practices, best practices, because this covers, let's say, like a basic of Polars language. So I hope you will find this useful and you can apply this in your real case scenarios. And please let me know in comments your suggestions and feedback. Thanks for watching. So let's see you in the next video.